Hello and welcome back to the channel. I want to start another module that is surface technique in CREO, and I'll be using examples to show you how you can do surfacing. And I'm going to start with our first example here. I'll show you how to model this one. I will start from basic to advanced. I'll be sharing these files with you. Yeah. I'll show you how to model this. Then on this we're going to build up something else that is a little bit advanced. Okay, therefore this one is a surface body. Let me go back. We start with a sketch. We are sketching a line there, and the sketch is on which plane? On the front plane, and orientation is right to be right. This means, just to explain for those who don't understand this, when we say sketch plane and reference and orientation, also it took me some time to understand. We usually have three planes. This is a front plane, right plane, and top plane. And you can see the right plane, if I was to face this front like that, the right plane, we can say it is either facing this direction or this direction. Okay, you can see it is either facing positive x or minus x. Same case applies to the front, to the top. It is either facing top or bottom, while this front is either facing right or facing left. Therefore, if assuming that I want to sketch something that will look like, let me see the best example. Yeah, something that will look like this, like that. If you to sketch something that looks like that, I don't want to sketch this face and extrude this direction. It is very important for you to understand how you're going to sketch this, because you can use any plane to sketch, but now it is very important for you to understand how to sketch that. And let me just sketch it again here. We just need this plane, that shape, and this shape. The most important thing for you to understand is this face is facing this direction, okay, while this bottom face here is facing this direction. Therefore, I'm going to sketch this one here onto this plane. If I sketch this in this plane, this one here will be, it can face, I can decide this one to face this direction or face the other direction. Therefore, if I sketch onto this plane, I can say sketch, then I can say here on the setup, top to face top, or I can say top face bottom if I want, but I want top to face top. And now I can sketch my shape here like that. Then I can say extrude. Yeah, This one is a basic explanation how to use that, but I'll be explaining to more details when I find more examples that make more sense. Therefore, here we are using what we call sweep. And the sweep surface is you need what? You need a trajectory and you need a profile. When we're sweeping, you need a trajectory and a profile here, like that. Therefore, you can sweep this along this trajectory to form such a shape. And you can now mirror to make it complete. This one method, or you can just make a circle and a trajectory and sweep like that to form a tube. You can do either method, but here we have a that sketch and a bottom sketch. Extrude. I'll show you the purpose of that extrude later. In this sweep, let's see the sweep. We have said we need a trajectory and we need a what? A profile. It's a profile. And we are sweeping this profile onto this trajectory. Like that. Okay? I hope you have understood how that. You just need what? Let me just use this there. For those who like seeing an actual demo, just need a sketch that defines the trajectory. I can say, let me create a spline here, here, there. That would be my profile, my trajectory or origin. Then I need to create what? We select this one here, you select this one here, then you say sweep, then you sketch. And where you see these lines, you see these construction lines, that is where you sketch. You see, like that. And don't worry about this, I will explain this into detail later. What is a variable section constant, section plane control? You have three: horizontal, vertical control. This one will change depending on whatever you select here. You see now this changes. I'll show you all those, and X direction. I'll do this later, all of them. Therefore, just that's a basic one there. Let me just delete this and go to isometric. Now we are going to the other task, and this one here you can just have a sketch and extrude. You can, I'll provide you this model, but the most important thing is the next, what we are going to do next. I want us to do this now. When you look this from this side, you see this one here, it has a constant cross section. Cross section here is constant. I want to vary this cross section such that it reduces then increases. Therefore, we'll have a variable cross section that starts big, reduces, then increases, like that. How can you do that? Okay, let's now go back to this sweep here and edit definition, or you can say Control A. You can select here. When you select a feature, you can say Control A to edit definition. Then we're going to select sketch. Remember, this is our profile. That is, we are sweeping this profile onto the trajectory, and it is an ellipse defined by two dimensions, RA and RB. This one is for the major diameter, this is for the minor diameter. You know that when defining an ellipse, you need those two. This is the shape of an ellipse. You need this dimension here that is which is the major diameter, and this here minor diameter. Then we are going to do something. We are going now to vary this. We're going to vary this from 4. We are going to reduce them as we sweep. This is what we're going to do. We have our trajectory here, and we have our profile here. As we move across the trajectory, we are going to vary this to reduce in size, like that. Then after we reach somewhere here, we start to increase in our size. That is what we are going to do, like that. Therefore, for us to achieve that, go to tools and select relation. You can go to mode or go back to sketch. You go to the tools here and you select relation. We can vary this using a relation. We get this relations dialog box. There is a function used by CREO only. That is one of the most powerful function for the CREO. That is called Trajpar. Trajpar. I type it here, you'll see. Let me just explain. Let me just say here. Let me just let it here for you. Trajpar. Trajpar means trajectory parameter. This is one of the most powerful function of CREO. Trajpar, whenever you use the word Trajpar, it is a function that returns 0 to 1. What happens is, assuming we have a starting point as here, this is the starting point, and this is the end point. At this point, the Trajpar, if you call Trajpar, it gives you 0. As you move along the trajectory, this one is as you sweep along the trajectory, at the end it will give you a value of 1. How can you apply this now? Let me just explain again here using a very simple example. Assume you have a horizontal plane and you're supposed to use Trajpar to create such a shape. Okay, and you can see this height here and this height here increases as you move across from this point O to point maybe B. As you move across like this height is changing. You can use like a curve. You can also have a linear. You can go straight as well. Even I can see the starting point here. I can say we have our starting point is H1. Our end point may be H10. Let me call this 0, H0. I cannot define this H10. I can say H at any given point of along this trajectory, it is a constant, that is H0 plus, I can say now plus, depending on the change. How am I changing? The rate of change. Okay, maybe I can say plus 20 times Trajpar. Remember how we say y equals mx plus c? This one is a form of a Trajpar, whereby we have a constant. This is my starting value of h0. Therefore, the y at any given point, I can say y at any given point is given by, now this is what is happening. This Trajpar is going to return a value of 1021. Therefore, when t is 0, we are here. When t is 0, we are here, because it will be h, it will be maybe, assuming your h naught is maybe 40, h naught 40 plus 0, here we are going to get 40, but here we are going to get 40 plus 20, we are going to get 60, but here we're getting 40. At t1, at not t1, at t0.1, we're getting something else, maybe 40 point something like that. Therefore, just the most important thing is to understand that Trajpar returns a value of 0 to 1, and Trajpar, as you see, as you're going to see, Trajpar is very, very powerful. Trajpar returns value from 0 to 1. You will see as you progress, you can also magnify Trajpar to return maybe from 0 to 100. You see that. Now I want to know this SD7 here. We saw SD7 was 4. Let me first for cancel here. Let me copy this here. Control copy. Yes. This is for 3.5. Okay. Let me go back here. Therefore, I want this value. I know this value. This one I know that. And comment it here. This is how you comment. This is 4 mm. This is 4 mm maximum. We know maximum is 4 mm. Max value is 4 mm. We know that. And we want minimum, because we are going to change minimum min to be, we can say minimum to be maybe 2.5 mm. Therefore, I'll say, and then I want this value to change, not linear, but to be like a sinusoidal. Therefore, I'm going to say SD7 here, SD equals 4. I'm starting with a maximum of 1. I'm going to say subtract. How do you get 2.5? Minimum 1.5. So that when you subtract those two, you get 2.5. Then multiply by Trajpar. Therefore, this one here will be Trajpar will start from 0. Therefore, 1.5 times 0 gets 0. Therefore, it returns a 4 until it reaches 1, whereby 1.5 times 1 is 1. 4 minus 1.5, 2.5, you get to minimum. But I want this to be sinusoidal. Therefore, I'm going to say Trajpar multiply by 180, like that. Then it is a sine. You can use a sine. You can use a sine. You can see 1.5 times sine of 180, but Trajpar, this means 180 is going to change from 0 to 180. That is how you can create a sinusoidal wave. Therefore, again here, I say this one is an advanced surfacing with me. Then we're going to now create another one for SD4. This one is SD4 here. You can say max of 3.5, min of 2.2, min of 2 mm. You can say now SD4 equals 3.5 minus how do you get to 1.5? Because 3.5 minus 1.5 you get minimum. You multiply by a sine of Trajpar of 180 and close the bracket. When you see this one here, tick to verify if there's some error. Relations are being successfully verified. There's no issue. You can say now okay. You won't notice anything because you are saying I'll start we are getting 4 and 3.5, but once I press OK, this will start to reduce. And I'm going to explain why I'm using sine 180. I'll explain why. Let me see this here. You see at this point we are reducing then increasing. We are using why am I using sine theta? If I don't use sine theta, let me go back to relation here. I want to understand. Go to sketch. I'm going to go back to relations here and remove sine. Then first of all, let me comment out. Let me copy this, paste it here. I don't want to delete. I just want to comment here. Then copy this, paste them there. Remove the comment table. I want to remove 180 here, Trajpar. I want you to see what happens. Trajpar. Again here, control copy, control paste. Let me remove that 180 and sine. You will automatically understand why. Verify, okay, okay. When I say sketch, okay. Now you can see, you can guess. Take a guess. As you can see here, without sine, this one reduces all the way to the end. What is happening here? Let me draw the graph. We are starting with a very big value here. We are here, starting point, to a small value here. Maybe we are here, but we are swiping. As you swipe along, therefore, this point, let me put it here. We are moving from this point to this point in a linear direction. The reason why we are moving from maximum here to minimum. But for me, I want to move two direction. I want to move like this. I want to move from maximum to minimum back to maximum. I want this one here. After this point here, I want it to start now increasing again. Okay, how can you achieve that? How can you achieve max, min, and back? What behaves like that is called a sine wave. That's how sine wave behaves. It starts from, you can start from minimum. You can either go the other way, start from minimum, go to maximum, and go back. You can see we are moving two-step. It's two-step movement. From here, go up, then come back. But here we are going the other way. We are starting now from the maximum to minimum. We are doing the other way, like this, like this. The reason why we are saying, and we know that a sine wave starts from here, goes to the maximum, then go to the minimum. Sine wave, that's how it does. And we know that from this point, it has to be 0 to 180. We are starting from somewhere minimum to maximum, like that. The reason why, when I go back now here, go to this one here, go to sketch tools, relations here, therefore delete that. I don't need this linear, delete that, like that. You can see now we are starting from 0. This one means 0. Remember we said Trajpar. Trajpar returns what? Returns from 0 to 1. Therefore, this one means that we are starting at where? 3.5. We are starting here. Minus the minimum will be 2.5 here, somewhere here. Therefore, because it is a sine wave, remember if I was to go to the other side, sine wave here, if I was not to go to this negative side, it will be like this. To make one complete, 180. Okay? But now you are starting from here. We are starting now from the 0. We are saying here, this here, it will return 0. This is the sine wave. We are starting from there to there. But now we are taking these values, multiplying them by 1.5, then subtracting. Basically, this SD4 will start from maximum to minimum. Then it will change from minimum to maximum. I hope that makes a lot of sense to you. Yeah, we'll do more examples of Trajpar. You'll see how they applied. Okay. Therefore, just know this. When you use Trajpar, we call it trajectory parameter in relation for sweep. It allows you to map a function along the trajectory, and the value for Trajpar varies from 0 to 1 as you sweep along the trajectory. Now, for the next thing we need to do is to merge. You need to merge this and this. Therefore, you're going to merge these two surfaces like that. How do you merge? Merge means to connect. Remember the surface I made here? And for you to merge properly, they have to intersect. Therefore, you have to merge this. Press Ctrl and that, and preview. You can see the dotted lines here. Dotted lines means this is the side CREO is going to preserve for you. But for me, I want the other side. You can swipe here. The first quilt you select, you use the side of the first quilt. For example, if I interchange here, if I try to use this, now it is selecting the second one, because now the first one is now this one here. How to use these arrows here depends on the quilt we select first. When you select this first, then this one here is going to control what to keep onto the rectangle. See, when I say, you can see now, because you said keep that side, therefore that's what we need to keep. I don't need this now anymore. We don't need this anymore. And lastly, you can now solidify that, and you have a solid. So that looks like a door handle. For you now to create this shape, whereby at the middle we have a small cross section, but at the end you have to use Trajpar. Okay, therefore from there, next now you can come here and you can say extrude. If you want to extrude your door, your actual door, now you can say center rectangle, yeah, like that. You can give it 1 mm. That's a very thin door, you can see. Yeah, let's make it at 5. Yeah, then you can round if you want. That you can shell if you want to shell, like that. Yeah, that's how you can make this here. And if you want to add some appearance, those who like appearance, yeah, you have to make such a shape using CREO. That is the technique you can use. You might ask, me, how do you prevent? You can see when I did a shell, I was able to shell even this here. How can you fix that? Such that when you shell, you don't shell everything, even the hardware shelled. You want your hardware to be solid. In that instant, when I go back to extrude here, there are several ways you can do that. But when I go, the simplest one is when you go to the solid, you create another body, call it create new body there. Therefore, this shell here is going to shell, edit the shell, then remove this and select this face. Not this for this body, this face, like that. You see? Then you can say combine these two bodies. But you see now, because you cannot share these, now you have something here. You can see what is happening now here. We can as well do something else. Control copy this and control paste. We are copying this surface. Control V, control paste. Let me see what happens when you copy this. I told you this one is actual engineering. Now we are doing. We have the surface. We can now use this. We can now solidify this surface here, and we can say remove material of. We need now to select the body option of body 1 here. We are saying solidify this our copy by using remove material option here to cut that excess. Then lastly, you can boolean. I'm using long method for you to understand how to use these features. It looks simple, but it's not easy. You can see. Yeah, then you can easy. Lastly, you can do a round and a round there, like that. Yeah, I really hope you have learned something in our lesson 1 today. Tomorrow we're going to now model, or next time we're going to model a little bit more advanced part. We'll be moving slowly because I want to teach you everything in CREO surfacing. From this one is for the from intermediate to advanced. But if you are beginner as well, you can learn a lot. But as a beginner, I would suggest you learn basic tools, how to use extrude, how to use datums here, because I will not be explaining how to use point, how to use spline, what is sweep head. I just was having a basic understanding. Thank you and see you next time.